So in this video, I'm going to talk about inverse functions. So an inverse function is how you would go back from the answer of your function back to what the question was. So if I had a function that when I input 2 and it gave me an output of 5, the inverse function would need to take the input of 5 and give me the output of 2, so to reverse what the function had done. So notation for this is if I have a function of x, then the inverse function, that would be the function, then the inverse function is written f minus 1 of x. That would mean the opposite function of f. So that would be the inverse function. Now, in order for a function to have an inverse, it needs to be a one-to-one function. If it's not a one-to-one function, then you wouldn't be able to have an inverse function. So let me give you an example. So if I had f of x is equal to x squared. Now, if I was to then do f of 2, that would clearly give me 4. Now, to have an inverse, I would need to take the 4 and get back to 2 again. But if I took the 4 and took the square root, I could have the possibility of 2, or I could have the possibility of minus 2. Since then, that would have one input, but it would have two possible outputs. That wouldn't be a function. So in this case, there would not be an inverse function for x squared. So this would have no inverse function. Okay, so a function can only have an inverse function if it's one-to-one. One input goes to one output, because then when you reverse it, one input on the inverse has to just give one output, otherwise it wouldn't be a function. Okay, so range and domain for inverse functions. If I have my function f of x, then what I put into it is called the domain. And what I get out of it will be called the range. Now, if I have my inverse function, that is designed to go back the other way. So if I take what I got out of my function and put it into the inverse function, I should get out back the same thing. So this would be the domain, because it's what goes into the inverse function, and what comes out of it will be the range. Now, these things need to be equal. What I put in here and what I put out here, I then have to take this and put it back in here and get out here. So the domain for the function should equal the range for the inverse function, and the range for the function should equal the domain for the inverse function. So those two items have to be equal to each other, because that's what an inverse function is. It takes the answer from the function and turns it back into the input. So the output from the function has to go in to the inverse function to give the same number we started off with. Okay, so the domain for the function has to equal the range of the inverse function. The range of the function has to equal the domain of the inverse function. So imagine I have a function g of x, which is going to be, I don't know, 4x plus 1. Keep it fairly simple first of all. Now, in order to find the inverse function, what I need to do is know how I would go back to the original input. So what I do first is, instead of writing it with g of x, I'd write it in a different form and replace the g of x with y. So I'd say y is equal to 4x plus 1. Then I would switch the x and the y. So I'd say x is equal to 4y plus 1, to switch them around. Then I need to rearrange the equation so it says y equals. So I'd start off by taking away 1. So I'd say x minus 1 is equal to 4y. Then I would divide by 4. And I'll sort of write it down the other way. So I'd have y is equal to x minus 1 over 4. Then I can replace the y with my inverse function. So inverse function of g of x is equal to x minus 1 over 4. So that should be my inverse function. I can check. So say I put in the value of 2 here, and I would do 4 times 2, which would be 8, and would give me the answer of 9. Then if I take 9 and put it into my inverse function, I should get back to 2 again. So if I did 9 take away 1, that would give me 8. Divide by 4, that would get me back to 2. So that would have correctly found my inverse function. Okay, so let's put everything together and look at a question. So this question says the function f of x is a one-to-one function such that f of x is equal to x squared minus 6x plus 16. And then it says where x is greater than or equal to k, x is a real number and k is also a real number. So this here, x is an element of that real numbers and k is an element of real numbers as well. So the first part of the question says find the smallest possible value for the constant k. Now, because it says here f of x is a one-to-one function, but f of x is a quadratic. So because it's a quadratic, it's therefore going to look something like this. Now, because it's got to be one-to-one function, and it's also got to have an inverse function, we can see it's have an inverse function down here. If I have one value here, I need to just get one, and when I come back again, it's got to be one-to-one. So if it was quadratic here, one output or one input could give two possible outputs, or one output could give two possible inputs. So in order for that not to be the case, I would need to have only half of it. So what I would need would be a line of symmetry down here, and I would have to just have the part on this side and not this part over here. Okay, so therefore my value of k would be where this red line is. Now, I haven't drawn any scale on here. I've just shown that you need to have basically half of the quadratic equation. You can't have the other half, otherwise it would be 1 to 2. One input could give two possible outputs, or two inputs could give the same output. That's what I mean. So here, if I had this value of x here and this value of x here, they would give the same output. So it wouldn't be a one-to-one function. Okay, so I can't have the left-hand side of the quadratic, I can only have the right-hand side of the quadratic. So my value for k is going to be where that red line is. So in order to work out what's going on there, if I delete that, in order to work out what's going on there, I'm going to need to rewrite this in the form of completing the square, so I can plot that on the graph and see what that formula is going to look like. So my first task is going to be rewrite that by completing the square. So for part A, I'm going to say x squared minus 6x plus 16 is equal to. And to complete the square, I need to take half of this number here and make it x minus 3 squared. Because when I square x minus 3, I would get x squared, and then I get minus 3x again, would give me minus 6x, and then minus 3 times minus 3 would give me plus 9. Plus 9 is okay, but what I need is actually plus 16. So from my plus 9, I'm going to have to add another 7 on to get my plus 16. Now, if you didn't really understand what's going on, I do have another video about completing the square, so you can go and check that out. So what we've got here then is this function rewritten in this form. Then I would be able to plot that on a graph, and if I just sketch that out, my quadratic would look like that. That would be a quadratic for x squared. And then what I've got here is a translation. So this would, because it's x minus 3 squared, it would translate 3 to the right and then 7 up. So my quadratic would be translated 3 to the right and then 7 up. It would look like that. So this point here would be 3 and this point here would be 7. Therefore, my line of symmetry, which I was talking about earlier, would look like that. That's not quite straight. That's better. So my line of symmetry here would be here, like that. And so therefore, I would only need to have this side of the graph, not this side, just this side here. So my value for k would have to be 3. Oops, I want to write that in. So k would have to equal 3. All right. Next would be to find the inverse function f minus 1 of x. So if I look at part B, my function f of x was equal to x squared minus 6x plus 16, which was also equal to x minus 3 squared plus 7. Now it's going to be easier to use this form to find the inverse function than this form, because here I've just got one single x by itself, whereas here I've got x squared and then I've got x's as well. So I'm going to use that form. I'm first of all going to rewrite it with y. So let me just write it y there. Then what I do is I switch the positions of the y and the x. So I would say x is equal to y minus 3 all squared plus 7. Then I rearrange it so it will say y is equal to. So first of all, I would subtract 7. So I'd have x minus 7, y minus 3 squared. Then I can take the square root. And then I could add 3, right any other way. Okay, like that, then all I need to do is just write that in the form with the inverse function. So f minus 1 of x is going to equal 3 plus the square root of x minus 7. Okay, that should be done. And then it says state the domain and the range for the inverse function of x. So if I look at my sketch for my graph, I can already see that if we talk about the actual function first of all, so the function, the range for the function, sorry, the domain for the function has to be what I put in, has to be greater than 3. So if I'm talking about f of x, let's write this in a different color here, x has to be greater than or equal to 3. And then the range, you can see here from my graph that it's going to, the output has to be greater than 7. It can't be less than 7 because the quadratic comes down here and the minimum point is at 7. So f of x has to be greater than or equal to 7. So for my original function, the domain is greater than 3 and the range is greater than 7, which means for my inverse function, they're going to be the opposite way around. So for the inverse function, so the domain for the inverse function is going to be the range of the original function, which is greater than or equal to 7. And the range is going to be the domain for the original function, which is greater than or equal to 3.